All right. Hello, everybody. Welcome to the High Performance HVAC podcast. I am one of your hosts, Adam Mufich, and I'm with my co host, Casey Contreras.
What's going on, folks?
And we are lucky enough to have one of my friends and mentors with us today, Mr. John Ellis.
What's
Um,
happening, guys? Thanks for having me.
thank you for being here.
Yeah, thank
And
you.
I wanted to. John is actually the guy who introduced me to NCI. So I wanted to thank you for that, and maybe you could quickly give a little bit of a story about the history with maybe me and you, and maybe we could talk about all of our history between the three of us, how we all know each other, because you know Casey, you guys have met in the past, right?
Oh, yeah.
Well, for a little context, I've been hanging out with NCI for, gosh, near 18 years. And I remember Casey's first day, for the most part, when he first
Yeah.
started. And then I remember when you first started, Adam. Yeah. And I took my very first commercial and residential air balance class from Rob Falk, bless his soul. And we miss him dearly. But one of my mentors said, "Hey, you got to get involved with NCI." So I got on an airplane. I flew to San Jose, California, and took his class, and it changed the way I did business, changed the trajectory of my career. And I owe a debt of gratitude to Rob and the NCI family. And it's been an amazing, amazing journey.
So I've heard a lot about Rob. I've never, I was not part of NCI, when Rob was still around. If you guys don't know, Rob passed. He was one of the co-founders of NCI. Just from everything I've heard, he's an amazing guy. But so you mentioned NCI changed the trajectory of your career. How so? Like, what did you start doing differently?
Well, how about measuring? Let's start with that. And, so one of my mentors, Scott Johnson, who was also a trainer for NCI at the California Training Center. And early on, he took me under his wing through an organization called iHacky. And I took every class. Once I got exposed to training, I took every class he had. I did all the NATE core, and then he started getting into airplane because, John, you need to take this to the next level. And so I did. And once I did that, NCI kind of solidified a lot of what I thought I knew about airflow and how it affects everything that we do in our industry. It was just an eye opener. So I took commercial air balance, residential air balance, and I took system performance. I took commercial system performance, and I took the combustion class, and then I took through Justin Bright, who used to be a trainer as well. I took the commercial economizer class. And then from that, it just like stacked and stacked. And then, of course, while I was doing that, I was running a parallel path with building science and getting really in depth to that. And then it led into indoor air quality. And, and everything is connected. Everything is connected. And so it was just an amazing journey. And after I took my commercial economizer class, I landed a job for Disney at their Imagineering studio in Burbank, California, and I must have. They were doing a big roofing project, and so they were lifting all the units, resetting them, but then they were adding new economizers to about 40 rooftop units, and they brought me in to commission them all, and we would work at night, and then during that class, I learned. So in the old days when we were setting up economizers, it was all linkage. So you loosen up the nut and you'd slide the linkage, and then you'd measure it, and then you'd do it again and again and again and again and again until you got to where you needed to go. But then some new technology, because it's always evolving. So I got to learn the Belimo controls and the Honeywell Jade controls worked off of millivolts. I'll change everything. And so we were able to, as to the engineer specs set our minimum and maximums, and then also set up for our free cooling based on temperature and enthalpy. And then that class taught me how to measure and calculate BTU gain and loss through an economizer, and yeah, just whole world of stuff, and it was amazing.
Nice. You mentioned you started to get into indoor air quality a little bit. So you dabble in that here and there. Is that right?
Yeah, I dabble, but let me make this statement right now: indoor air quality, IAQ, and indoor environmental, because it's not just indoor air. We're literally changing environment. So indoor air quality slash environmental, building science, and HVAC are inseparable, inseparable, and you have to look at all three when you're doing any kind of diagnostics and trying to solve problems and create scopes of work. You have to look at all three. They're inseparable.
Yep. And we're talking about indoor air quality right now, right? And the way I first met you, it was funny. I got referred to you by Nate Adams, right?
Yeah,
We were going to have a discussion on the HVAC Overtime podcast about indoor air quality with a guy, a huge YouTuber named Big Clive. So
right.
you and Clive had a debate, and we thought it was going to be a knockdown, drag out type deal, but you guys were very courteous and polite with each other. So it was anticlimactic a little bit. Um, but yeah, no, John is I was being a little bit funny and sarcastic a little bit. John is probably one of the, if not the best in indoor air quality in the country. So
I share that with others, but I like to think that yeah, I'm one of the premier IAQ guys in the country.
yeah,
Yeah, I remember when he pretty much one of my first days, first training classes. I heard he was coming. Boy, I was sweating bullets because I knew who he was, and I heard about him, and I knew he was the IAQ guy. And yeah, that was interesting.
Yeah, yeah, and that was in California
Yeah, oh, yeah,
at the training center. Was that the one that was over at the government building?
yeah, yeah. I think we
Yeah,
had like 40 guys in that. It was a massive class.
yeah, it was a good class.
Oh yeah,
Good class. Yes.
yeah. I tried to convince several different supply houses to bring John in to do training, and nobody. There was no takers. Nobody would bring him in. So if you remember correctly, John, I hired John and I put my name down to flip the bill, and then it was my job to try to fill the class. So I uh, I found a supply house that said, "Yeah, you could use our training room." And man, I was sweating bullets because this guy doesn't work cheap. I'll tell you that. But that was one of the most game changing classes that I've ever taken, and we talk a lot about installing the benefits of installing stuff like those different little gadgets and gizmos that you hang on the side of a duct and how well they work and that not true. We talk about cutting the cords on a lot of them because they don't work. But
Yeah.
why don't
Yeah.
you talk a little bit about some of the like what are things that guys if people don't know about indoor air quality, what should they be paying attention to and what should they stay away from?
Well, since you touched on gizmos and gadgets, ASHRAE, I think it's standard 185-3 or something. Am I quoting that right? That is the new ASHRAE standard that's going to look at these devices and determine if their byproducts are going to be harmful or helpful to occupants of a space. And does the benefit of having a device like that and its byproducts outweigh any kind of good that they might do when we're trying to come up with a solution? So I haven't had a chance to really sit down and read the whole thing because that's going to take a minute. But that's kind of the direction it's going. So I'm happy to see that come into play and get implemented. And so, so to your question, people always ask me, "Hey, John, what's a good strategy?" Or, "Hey, what's the best IAQ product that I can use?" And my question is always, "Well, what are we trying to achieve?" So we need to be customer centric, right? We need to focus on the customer and what are their goals, and so what are we trying to achieve? And so I like to lay down my basic foundation for good indoor air quality and my six key principles, and those go in the line of thermal comfort. We are in the comfort business, and so we should at least have a good understanding on what that means. And so and then it would be filtration is a good solid approach, and all that's entailed in filtration. And understanding that we just can't slip a filter into place and call it a day, that some filters have a high restriction, need to be designed into the system. And then, ventilation. ASHRAE 62.2 is really starting to gain traction. It's been around for a while, and it moves across the country, but I think a lot more municipalities are starting to pay more attention to it. And again, it's a minimum standard. And as we know, code is a minimum code, but it's a step in the right direction. So ventilation, let's put the V back in HVAC. And then we're going to move to humidity control. That's huge. Too much or the lack thereof. And so, and I always say in my class, if you remember, that the why never changes, just the how. How you do something in California, Arizona, Utah, Nevada, right? New Mexico is going to look a lot different than how you do it in Alabama, Georgia, Florida, Louisiana, right? And even Illinois, right? It's going to look a lot different. And so, up in the north in Michigan and Minnesota, they deploy both. So they do dehumidification in the summer and they do humidification in the winter. And then they've got good ventilation strategy. So they've got such a big swing temperature wise and climate wise. So know your climate. So the why never changes, just the how. How you do something is going to be huge. And then being able to design a system. And so when we move from ventilation, we're going to dip our toe into building science, and that would be looking at infiltration. And when we're talking about thermal comfort, that starts with understanding what capacity do we need, and that's doing a good solid load calculation. And even if it's just a block load to start, and then we move to a room to room, because basically a lot of municipalities will just want a block load. Well, that's fine, but if we start to really look deeper, each room orientation, different things are going to need different requirements to satisfy the load for thermal comfort. But in doing a load calculation, one of the biggest misses is our infiltration number. So there'd be a blower door number. And take that and put that into our software, because dumb data in is going to get you dumb data out. But that's one of the biggest things that is missed by a lot of people just doing a block load and trying to get close. So when we look at infiltration, then that moves us to pollutant identification and source control. We can't fix what we don't know about. And if there's a certain pollutant we need to address, well, we need to know what it is. And is it inside the house? Is it outside coming in? Are we bringing with us all those different pollutants? Are we bringing humidity? Are we bringing dust and dander and VOCs into the house by way of infiltration, right? And so that's my six key principles, my foundational things. We get a handle on that and really be able to put numbers, because if you don't test, it's just a guess. And NCI says if you're not measuring, you're just guessing.
Yes, sir.
Yeah, so I always say if you don't test, it's just a guess, because I like to rhyme. I'm going to turn that into a rap. But if we can get our arms wrapped around, our minds wrapped around those six key things, that really puts us on a good path to understanding indoor air quality and what it is we need to do. Now, it goes a lot deeper than that, but that's a good starting point.
Okay, so we did mention the gadgets. I want to bring it up one more time. So when you have certain products that come, and I don't know if I think this was you who said this, but IAQ doesn't come in a box. Is that you?
That wasn't me. My key phrase has always been prescription without diagnosis is malpractice.
Yeah.
Yeah,
So
because as soon as contractors hear indoor air quality, they're like, "Oh, hey, my supply house just had a sale on insert name of this gadget here, and I got them on the truck, and I'm going to get $200 if I sell them, and my boss wants me to sell them out." And so that's what they do, and that is malpractice.
and what are some of the I know we went over quite a few of these in your class, but what are some of the dangers and some of the byproducts that these products and gizmos generate? Like what goes into the air?
Okay, so let's so the use of ozone has been around a long, long time, and it works great for remediation, but not, and it can work great for breaking down pollutants, but it's not great for us, the occupants. So the EPA and the Air Resources Board has really kind of put the squash on ozone generators. And so there's some products out there that do generate ozone, but then they put this neat little thing in there to remove the ozone after they generate it. And so again, what are we trying to accomplish? And so I've always been an advocate of using UV lighting if it's installed properly and it's working on a surface and done right, right? But if dust is your problem, then that's not the answer, because guys will put it in as the the pot of gold at the end of the rainbow and unicorns and it's going to fix everything. No, it's not. It will treat the surface of a coil, but if you need to treat the surface of the coil, the bigger question is why. And so it's going to take us many directions. And so then if we look at ionization, we could call it needlepoint ionization, bipolar ionization. And there's many different forms of ionization, but basically it's putting negative ions into the air, and then those ions will attract to particles. And so we've got negative and positive, and ions happen naturally, but opposites attract. And so the idea is we're going to introduce the negative ions, and they're going to go into the air. Particles are going to become negatively charged. They're looking for a positively charged, and they're going to start attaching to one another, clump together, and two things. One, they're going to become large enough to get stuck in a standard filter. And then two, they're going to become heavy enough to fall to the ground. And then it's up to us as occupants to go ahead and vacuum those up, hopefully with a HEPA vac. Otherwise, they'll just get aerosolized. But the problem is anybody who has young children, especially toddlers and infants, they play on the ground, right? Or they're in a crib that's low to the ground. And so we've got these particles that are charged. They're looking for a place to stick. And they may or may not find their way to a filter, so they fall, and those young children are going to breathe in a particle that's been charged, and it's looking for a place to stick. Early childhood asthma is on the rise. There's been connection to ADHD and cognitive and different things. And also, so if we have a particle that's in the air that's charged, and then we have a low return air, and hopefully that particle can make its way to that return air, and then it's questionable whether it's going to stick to that filter depending on the quality of that filter. What's in between this particle and that low return? Me. I'm in there. And so is that system designed well enough that we have enough ACH per hour, right? Air exchanges per hour. Is our throw and spread on our design good enough that we're getting mix? A lot of times we don't even have good mix because people want to leave manual T out of the equation, right? So you have to do your calculation for load. What capacity do we need? Then from there, people go right to a manual D. No. You need to go to manual S for your equipment selection to understand where your design criteria is from that specific piece of equipment. Now we can do our manual D. And then if we discount our manual T, our termination points, do we have throw, spread, and does the air have a pathway back to that return air? And so if that isn't happening, then a charged particle isn't happening. And so then the other side of the spectrum is we do photocatalytic oxidation. And so that is the introduction of a UV spectrum across a catalyst, which is titanium dioxide. There's a chemical reaction which creates a hydroxyl radical. There are some products that claim that they make hydrogen peroxide, but anybody wants to do a quick Google search on what breathing hydrogen peroxide is all about, it's not good. Oh, well, it's such low levels, it's not a big deal. Well, then the efficacy isn't there. So then why do it? But the byproducts are formaldehyde. It's measurable. Nitrous acid in trace amounts, and then carbon dioxide. So we've got a home with high carbon dioxide because we've got zero or substandard ventilation. Then we don't want to add that to the space. But those are some of the byproducts. And so a lot of these guys, and I've called them all, oh, well, it's negligible, John, it's trace amounts. Yeah, but if that's what you're touting as the standard for what the technology of your device is, then you're kind of contradicting yourself. If you're saying hydroxyl radicals and the hydrogen peroxide is like, that's what we're doing, and that's the magic sauce, but it's such low amounts, it really isn't going to, well, then you just went backwards. Here's another thing. When you put one of these air devices, usually in a plenum, and so you've got a plenum, whatever that is, and hopefully it's designed with net free area to move a certain amount of air at a certain velocity into a duct system based on design criteria. In order for the air to be treated, it has to go across a PCO. And so we've done the math every which way from Sunday, and you're really only treating about 10 to 12% of that air as it goes across that device. And so as that 10% of air that's actually treated and hopefully had some benefit, some efficacy, right, enters back into the house, mixes with untreated air, now we've got the law of diminishing returns. Oh, well, we need multiple passes. How many? So 10% of the air goes back in, it gets repolluted, and now we're down to 2% of treated air that goes back and goes through, and there's no guarantee that that 2% is going to go across that element. Maybe it's part of the 90% that doesn't. It's the law of diminishing returns. We're not getting there. We are not getting there. So those are some of the problems that we have looking at these devices.
John, you just blew my mind, man.
Oh, I'm sorry.
Woo.
Do you want me to go slower?
No,
Just teasing.
no.
Just teasing.
What? I mean, when you step back and look from what we deal with every single day, it always comes back to design and the proper stages of design. What are some, if there is any not simple, but say you got a customer on fixed income and they can't tear everything out and start all over again. Is there anything there that we can do to improve their indoor air quality?
You know, Casey, that's I'm a bleeding heart. Fix the world.
Oh yeah,
kind
we all
of.
are. Yep.
And I've done my share of getting on airplanes and flying across the country on my own dime and working with families of children who are severely compromised. And so we do what we can do when we can. Yeah. And so if I've got somebody on a fixed income and not the stereotype, or maybe they're in a modular home or a mobile home, or they're in housing and urban development kind of situation where landlord's not keeping up the place, man, it's tough because they barely got enough to do a service call when the AC goes down. Yeah. But the Rosenthal cube, if we get 4 2-inch filters and tape them together with a $20 Walmart box fan on top, my goodness, that goes a long way. Run it in the bedroom, at least we can knock down our particulate levels, and it does a great job on PM 2.5, and it's great for a room. and it's about $60 maybe out of pocket. Maybe you can do it cheaper than that, and it's a DIY project. Well, hey, maybe we do that. All the way to, hey, I've got a portable air purifier in my room that does my room just fine, and it's $1,000. So that obviously is out of reach, but that cube really does some heavy lifting for a room, and
That's
it's
awesome. I thought that was a joke. That's good to know.
absolutely not. I've measured them. Yeah,
Sweet.
I measured PM removal in it, and they're doing 80-90% removal on your 0.3 microns. They don't do a whole lot on PM 2.5, but they do some. They act. He said do. They will after they load a little bit, depending on the filter, they'll start to pick up some PM 2.5, and that for those of you at home, that PM 2.5 is really small size range, and so it will do some work in that range.
That's cool.
Yeah, I was kind of thinking about it. What size filter did you say that is? That you
It's a 20 by 20 by 2.
20 by 20 by 2.
Yeah,
So you
because
start looking
a
at the
box.
surface area.
Yeah,
It's
there's
adding
four of
up.
them.
You could probably even elevate the fan and put a fifth one on the bottom.
Yeah, if you wanted to get fancy, if you're a good DIY guy, put it up on legs. You could, but that's a lot of surface area. Piece of cardboard on the bottom, run that box fans, because those Walmart box fans are about 20 by 20.
Nice.
Yeah. So
That's awesome. I wonder what kind of airflow those box fans move. And obviously, you have what, 3 or 4 speeds you could choose from. So you could,
three.
yeah.
So yeah, before you go to bed, you put that sucker on high. It's going to be noisy. Let it run for an hour or two. When you go to bed, you knock it down to a lower fan level so you can sleep. But they're doing some work.
I have a question I wanted to ask you. I've actually been wanting to ask you this for quite some time now. A lot of the new construction homes by us, and I think it's kind of everywhere in the country, to satisfy you. You brought up ASHRAE 62.2, which is the residential ventilation standard.
Yep.
ASHRAE's residential ventilation standard. But a lot of times, what they do is they bring in an outside air duct, a ventilation duct, and they tie it in directly to the return
Yeah.
of whatever system is heating and cooling, right?
Yep.
Um, I wanted to know your thoughts about that because I have a hesitation like thinking about that, and I think there's dangers in my head, and I just wanted to know if I'm thinking about this right.
Sure.
Does that work well?
Well, the why never changes, just the how. Could I possibly get away with that in California? Well, absolutely. The temperature's like nirvana most of the time, unless you're in Palm Springs, of course, or Palm Desert. Uh, so you just have to understand: am I bringing in a small enough percentage to fulfill my standard, which is a minimum standard, and be able to overcome that with the standard function of my equipment? So that's going to be the question. Can you do that in Louisiana? Well, I sure hope you don't. Another way we're satisfying that standard is the whisper quiet bathroom fan, and so that you put in some numbers and it'll turn that fan on and run it for a certain amount of time to kind of fulfill that standard. But the problem is they're depending on pulling that air from infiltration. So it's going to just pull some air from wherever we get it, and so that's problematic in and of itself. But that has been what I've seen in Energy Star homes. That's how they're taking care of that requirement. Yeah, I think it's Panasonic Whisper Quiet, and I like the unit. It's a good unit, and they come with humidity. They'll activate with humidity in the bathrooms and stuff. But they have one where you just put in your I think your cubic feet or there's two different samples. So when I started doing ASHRAE 62.2, it was if you are at or below 0.35 air exchanges natural in a home, you shall introduce mechanical ventilation. But the new chart now is based on, I think square foot or cubic foot and the number of bedrooms. And then you just follow the chart. It says you need 40 CFM, per hour, to fulfill the standard.
Yeah.
And then there's also, depending on the climate, there's also thermostats that you can plug in your ASHRAE 62, and it'll turn the fan on if you've got a duct coming, to your return air, and it'll run that fan for X amount of minutes every hour on the hour to fulfill that requirement. So,
Okay. So the one thing that I've worried about with ventilation that way, at least in my area, because I think Ed Janowak from ACCA, he always calls it like you either live in a green grass state or you don't, and it's you have humidity or you don't, and
yeah,
we have humidity. It's not as
yes, you do.
bad as Florida or Louisiana, but we get quite a bit of humidity. So my thought is, if you're introducing unconditioned outside air into, let's say it's 90 degrees with high humidity outside, into a cold duct, what could happen? And then also on the flip side, when it's negative 10 degrees outside and you're introducing that into a warm duct, and then in our market, we usually have a filter slot at the equipment. It's not, it's the, nothing's filtered. It's the last case scenario, the filter before it hits the equipment. So my question is, there's a potential for dirt in that duct. So we have dirt, and then it's dark, and we have a possibility of condensation in the duct. And depending on how you mix it, and if it's insulated, the return drop and everything else, that's what makes me nervous.
Well, yeah, and you're bringing up an excellent point, because there's all this talk about relative humidity or absolute humidity, and like, oh, we need X amount of RH, and what's a good spectrum, and it's like, oh, 40 to 60%, that's kind of like the magic numbers. I'm like, that is dangerous. Because you get up north and you're bringing in, and you're trying to achieve even 40% relative humidity up north in the summer, you're going to rain. And so we need to be paying more attention to dew points. And so if you've got operating conditions that are conducive of hitting a dew point in a return air, or bringing in outside air, well, we're in trouble. And so then that's where, and it goes without saying that the dehumidifying ventilator, Santa Fe's got a great one, and there's others, and we're really starting to look at that. And so if you have just an outside air, maybe something as simple as an enthalpy sensor, right? And it'll measure, and it's like, what, let's go ahead and close this damper, or even a humidistat that says, you know what, you can use some relays, normally open, normally closed, spring shut, however you want to do it, however you want to configure it. It's like, you know what, we're outside of our operating condition, let's go ahead and shut this down. The problem with that is if you're really depending on ventilation as part of a solid IAQ strategy for a multitude of reasons, mostly dilution, right? If you're depending on that and you're outside of those operating conditions for a month, a week, it could be prolonged. Well, you're going to have little to no ventilation, and then you've got some other problems that can arise. So we're always fixing a problem or uncovering a problem, well, only to find another problem. And so therein is a problem. And so, to your point, I'm working with Dust Free right now on a new apparatus that is going to be dovetail with any ventilation strategy on the market today. And so we can now, it's going to work in tandem with an ERV, an HRV, maybe just an outside air duct, maybe with my main goal was to work with a dehumidifying ventilator, because as we're solving one problem with ventilation, we have the potential to create another problem. So as we're bringing air from outside, we have the potential of three things. You're going to start hearing more and more about ground level ozone. Back during the industrial age, those levels climbed and got up to like 60 ppm ambient outdoor. We really started to look at that, and the invention of catalytic converters and getting a control on emission. Those levels have come down below 50 ppm, but more recently they're starting to creep back up. So once you load a house, it is really hard to unload a house, especially if you're depending on ventilation to help you with that. So if you're bringing in ground level ozone, problem. 2.5 PM, 2.5, or any PMs, coming in because most of those outside air apparatus have a MERV 8, maybe a MERV 13 on the better ones, but it's not a tight filter. So there's a lot of bypass. So if we're loading a house with PM 2.5, that's a problem. And then of course we could be loading a house with VOCs, depending on where you're at, whether it's agriculture, it's industrial, freeways, you know, a multitude of sources that are outside. We could be bringing those in through our ventilation strategy. So my apparatus is going to have a true HEPA filter and 10 to 15 pounds of carbon. It's going to have a reverse incline digital fan that can handle up to 1 inch of static pressure. So whatever air we need to bring in to satisfy our 62.2, my machine will clean it up. So it's already being dried out. So dehumidifying ventilator, I will dry it out. Then I will filter all that PM completely out, 100%. And then that carbon will remove ozone and VOCs completely out of the air and then deliver it to wherever it's going. And so that's what I'm working on now. I've done my initial design. We've done our material procurement and kind of market analysis. And then I handed it over, and they took it from there because they look at raw materials and other things that it takes. Manufacturing is a trip. This is a new gig for me, and it's fascinating. But right now, it's going up the flagpole. I'm feeling pretty confident because there's nothing on the market like it. We need it, and I got guys that are smarter than me and said, John, we need this yesterday.
Well, I'll send you my shipping address so I can try out the first demo.
Yeah, be my beta.
Nice. You mentioned, you're throwing out all these terms, and for the guys that have not taken an indoor air quality class and they're not up to speed on all this, can you talk a little bit about like what is VOCs, what is PM 2.5, what are these different numbers that people need to be concerned about and should be measuring?
Yeah, VOC is volatile organic compounds, and which is kind of deceiving in its name because they're not always organic. Sometimes they're synthetic. So that's a large group. We have 16 kind of prominent VOCs, but there are more. And to name a few, formaldehyde, benzene, dialene, xylene. There's a lot of attention being given to microplastics now, and their composition and how they break down. And that once we look at those compounds, that's going to add to the list. And then PM. So we look at PM stands for particulate matter, and so we've all been in a house with the sun shining through the curtains, and there's the little sparklies in the air. That's PM. Those are rather large. Most filter manufacturers test their filters for PM 0.03 or 0.05, and so that's rather on the larger side. And as you go up the spectrum to PM 2.5, we're getting very, very small. And the problem is when they're ingested, they go into the lungs, they enter the capillaries, they can enter the blood system, and from there it goes everywhere into the organs, into the brain, into the heart, into the vascular system. And so there's a lot of attention being given to 2.5 right now, as it should be. And I'm surprised it took us this long to really start looking at it. Did I answer the question?
Absolutely. And then what about a HEPA filter? Like if somebody's thinking about a HEPA filter, what's the difference that the product that you're working on versus like a regular 1-inch filter or a media filter? Like is it that much better? Can somebody just throw together a 1-inch 3M filter in their ventilation and call it a day?
Sure they could. Just because you could doesn't mean you should.
Yeah.
In our market, we have a MERV rating. It's a minimum efficiency rating value, and it's the standard set forth by manufacturers so we can all play on the same field. So we have some kind of standard to put our products up against. It goes from 1 to 16. Most 1-inch filters that we get, like from Flanders or for HVAC, they're like a MERV 4 for a 1 inch filter. When we get into the 2 inch filters, they go up to a MERV 8 to 13. When we get into extended pleated media, which means 4 and 5 inch, we start to get into like MERV 15. There are some claims of MERV 16, but as we get, and it ends at 16, so 1 through 16. MERV 16 is just a step or a click below HEPA, because a MERV 16 can achieve like 95 to 98% filtration, but a true HEPA can achieve 100% filtration in a multitude of size ranges, including ultrafines. And so, but then we have to cause and effect, right? Everything's a cause and effect. As we get up higher into our MERV ratings, our resistance climbs as well. So we need a filter be able to move a certain amount of air at a certain velocity through a certain amount of net free area, right? To achieve a certain amount of CFM with a certain amount of resistance, right? That's the static resistance. As we know, and if you're NCI, static pressure goes up, performance and airflow goes down. I've been measuring this stuff for 17, 18 years now. So, yeah.
And that's interesting. I'm a member of a couple different Facebook groups where there's HVAC professionals that give homeowners advice. And a lot of times I see people saying like, "Hey, what?" They ask, "What MERV rating should I buy?" And almost all the time, everyone says, your HVAC equipment can't handle anything more than a MERV 11. You should not never use more than a MERV 11. And I know you kind of touched on this a second ago, but will you speak to that a little bit?
Sure. So the way they phrase that question, and I've seen those conversations, what they're saying is, hey, if I were to pull the filter out that I have now in place, what's the max filter I can slide back in and call it a day? So we need to put some context to that question.
Sure.
And I think it's pretty accurate to say that a MERV 8, might be about max it can help. It can handle. I've got in my presentation, I got a slide using a furnace, and it's a 3 ton, so we're 1,200 CFM. That allergy buster from 3M. Now I've tested them on particulate removal. They are fantastic, but they are a giant killer. You slide one of those in a 1 inch filter at 492 feet per minute velocity at the machine, right? You are going to have a 0.58 static drop across that filter. You just killed everything, killed it all. Does that make sense?
Yeah. So that means you could never use a 3M filter. That's what you're saying.
I wouldn't advise on it. It has to be designed into a system.
Right.
Yeah.
No, but the point I was trying to make is like any filter, you could use higher MERV filters. You just need to design for it. You can't just arbitrarily switch out a filter and think you're going to make a difference.
Yes, and that's why I wanted to put some context to that question, because it's at face value, it's not really being phrased properly. But yeah, that's what they're looking for.
It's
A swap.
a loaded question.
It's a loaded question. I love loaded questions.
Another thing I wanted to bring up was we just about a week or two ago, it was all over the news that Chicago, that is where I'm from, we had the worst air quality in the world for a matter of maybe 2 days.
Yep, I saw
And
that.
so that was pretty wild. It was like it's almost like you were walking around in a dream, and it's like a haze outside. It was wild.
Yeah.
So what is everyone supposed to do if they have ventilation tied in and they're sucking all that into their house? Like, what do you recommend in a situation like that?
Yeah, and so having the ability to go throw a switch or unplug something would probably be smart. I wish we kind of are to the point where, like with the Haven IAQ, if the TVOC levels get too high, that maybe it can shut down an outside air. Because we can shut it down for humidity, we can shut it down for temperature. Why shouldn't we be able to shut it down for temperature? So and so we don't design for the 2 days out of the year, and we design for the other 363 days. And so that's a loaded question. And early on in my career, I was trying to come up with a way to do something that would help us with that. And that was 20 years ago, but the sensors and stuff I were looking at were not that robust, meaning they'll work for a while, but then they get corroded, they get inaccurate, they stop working, and then to change them out. So they've gotten a lot better, and so yeah, so that's a loaded question. And so um, you know your friend Chris that lives out in the Inland Empire.
Yep.
He's got some bad air quality there as well. And the thing is, it's not even generated there. We have this weird phenomena that runs through Los Angeles like a trough and pushes everything into the Inland Empire.
Yeah.
Then we've got a ridge of high pressure that comes off the desert behind the mountains and pushes. And then we've got the offshore influence of cold air that pushes and just sandwiches everything right there in his backyard. And so you had that phenomenon of the worst air too, probably because of some weather patterns, barometric pressures, offshore influence, and different things that just kind of squeezed it all right into your backyard.
Yeah, I think we got hit with the Canadian wildfires as well too. So it was like the perfect storm, if you will.
Yeah, and yeah, that's been happening a lot. What was it? 2 years ago, it was like crazy. They've been having a lot of trouble with wildfires. And then I did an episode with Grapevine, and we talked about all the byproducts that come off of wildfire, depending on what the fuel is and the humidity content, and like arsenic and creosote and PM 2.5 and smaller. And there's a lot of bad stuff. And depending on the fuel, I don't know if you know or not, but I was a firefighter, and I was in LA. So I was a hot shot, and there was a couple instances where we were fighting a wildfire through poison oak, and a couple of the guys
Ooh.
got blisters on their lungs from breathing the smoke with the oil from. Even though we had masks, we didn't have respirators, but then they would have got a rash around the respirator. But they were in the hospital for a long time. So what the fuel is, how hot it burns, and all that stuff. It's bad. It's bad stuff. Yeah.
Wow.
I just retired from the fire department here in New Mexico.
Nice.
Yeah, turned in my gear, and it was a great experience. Volunteer.
I'm learning something about you all the time, John. John was like a rock star.
Yeah.
You've touched on everything. You know,
I've
so
been
cool.
been in the movies. Was a professional skateboarder, and
Yeah, very cool.
it's the
Um,
Forrest Gump.
you you know, we were just talking about wildfires and what smoke, how bad smoke can be, and that. Um, what do you think about these people that are in their house all the time burning candles? Because I ask you that because I didn't think candles were that big of a deal until I took your class.
Of course.
And then just kind of hearing it. So I want to get your take on that. And
Yeah. So a scented candle is 100% chemicals to make the scent, whatever that scent may be. Okay. So that's lovely smell you get when you walk in the house is 100% chemicals. Two, we got an open flame. What do you get with open flame? Soot, right? What else do we get from a candle that's burning and it's not burning very complete? Carbon monoxide, right? So it's the trifecta. So you're getting chemicals, you're getting soot, PM 2.5, and you're getting carbon monoxide. Now, is it enough to cause a problem depending on how drafty the house is or if they got ventilation? Well, maybe not. And which brings me to a point that I really didn't touch on when we're talking about air purification and some of the byproducts, and how they say, oh, it's such a low amount. And I tell a story in my class about a lady that I saved her life. She had a big box store carbon monoxide detector, never made a peep. And I get there, and she had a defective uh, uh, fake fireplace, and there was soot everywhere. And I asked if she burned candles. She said no. And once I pulled the porcelain logs aside, there was a big flame about 4 inches tall, orange like this, soot coming off of it. She was getting exposed to low level carbon monoxide for a long period of time. Headaches, cognitive, drowsiness. Her muscles were deteriorating. And
Mm-hmm.
it's like, so what happened? Well, the landlords put all new doors and windows, brand new vinyl slider, all new doors and windows. That's when it started. They took away the natural ventilation. So the point of that story is low level, long term exposure to any pollutant can have extreme adverse effects on a variety of people depending on where their compromised level is or where their health index is. Does that make sense?
Oh
And
yeah.
so the same thing stands true. I went. I was doing a ride along, and we walked in, and man, I could smell the candles, and I was literally getting a headache. And during our talk, it's like, hey, is there anybody in the house that has any asthma, allergies, any respiratory things we need to be worried about? She's like, oh, my daughter's got really bad asthma, and she mostly stays in her room. And I said, ma'am, you need to stop burning these things. And I got my air device out, I plugged it in, TVOC spiked, redlined. And I said, it's because of this. This is not good for you. They were elderly, but not good for your daughter. And it's, oh, I didn't know that. Well, education. And most people don't know.
Yeah,
No,
you have oh, go ahead.
I dabble in CO a little bit. Um, isn't there some common health effects that a lot of people go through? They go to the doctor, just common things that we run into every day, but CO, low levels of CO can cause, right?
Well, sure, because we as a society have a habit of treating symptoms and not the cause. And so early carbon monoxide exposure can look a lot like carbon dioxide exposure, can look a lot like TVOC exposure, chemical exposure, can look a lot like the common cold or allergies. And so, if we're too hyper focused on the symptom and not really looking for causes, it goes undiagnosed. This lady went undiagnosed for a year.
Yeah.
And if doctors, and of course, that's a special test that they need to do to look at those levels. They look at oxygen levels and other things. But that's a test that they could do, and they would have uncovered that a lot earlier if only that was the direction. But we always want to go a different direction.
One other I wanted to bring up one other thing. We talked about candles a little bit, but, John, you have something that you talk about in your class, and, you call it your I think it's called the no-fly list. Is that correct? Did I quote that correct?
Yes, you did.
So
Yeah.
there's certain products, and actually my after I took your class immediately, I called one of my aunts because she has one of those products that she uses in her house, and she has them all over her house to make it to smell fresh and that, right? And as soon as I took your class, I'm like, throw them all in the garbage. They're terrible for you. There's a reason why they smell, and it's not natural, right? So that like your no fly list or uh, that was something that was like eye opening to me, like paying attention to different things that are around people's houses that can also have a negative impact on their health.
Oh, absolutely. And one of the things that I do during my IQ or environmental audits is I go ahead and get under the sink and see what kind of cleaning products and different products they're using. I also would like to look at what kind of cosmetics they're using. What are they using for laundry soap? And then what do you guys got in the garage? And so scented candles are at the top of that. Also, those little candle blocks that you just melt, right? Those are
Hmm.
in there. Incense, totally no. Um, uh, so any kind of air freshener, and Febreze is at the top of that because they use a lot of surfactants in it. It's chemicals, and even if that wasn't enough, just the propellant is bad, right? Just the propellant because it's not food grade, right? And so, but all of those are in it. There's certain kinds of detergents that may not be as friendly, and that's case by case. And dryer sheets are really bad, and they too use surfactants. But that little dryer sheet, it ain't worth a plug nickel by itself. But once they put all those chemicals and stuff in it, that's what makes it valuable because it smells good and it's supposed to, get rid of static pressure. I mean, static electricity on your clothes. Yeah, you see where my
Throw
mind
that into
goes,
your
right?
Oh yeah.
furnace.
But so that becomes a problem. Murphy's oil soap. A lot of people use that. Pledge on furniture. That stuff is not good. Now, am I telling you not to do your furniture? Well, yeah, do your furniture, but maybe you want to open up a door. I mean, because that's been our go-to, right? Everybody knows what Pledge is. Lemon scented. There's other products that are a little easier. Cleaning chemicals is another big one, and it just depends on the person too. How compromised are they? Are they leaning towards more organic? Or are they more synthetic? Do they have multiple chemical sensitivities? Is that the spectrum they're in? Then for sure we need to pay attention to that group. Are they more organic? Do we need to pay attention to dust, molds, pollens, and different things that come in the air, dust mites, rodent feces, different things. Mice feces is a big one because when it dries, it crystallizes. When it crystallizes, it gets disturbed. Then it gets airborne. Even just rodents in and of themselves, especially if you have an infestation, they have an exoskeleton, right? And when they shed that exoskeleton, it releases an enzyme, and that enzyme is what a lot of people are affected by. And then when we talk about molds and pollens and different fungi and different things, there's a lot of talk about mycotoxins. But if you talk to the medical community about that, the percentage of people having a reaction to mycotoxins from a mold exposure is a lot lower than you think. There are more people that have a mycotoxin type of reaction from grains and cereals like rice and wheat and corn and different things than actually from ingestion and not inhalation. And so it's interesting, and I've been able to listen to a couple of people that are really really awesome in that. I did a mold summit with Got Mold. Man, they got some heavy hitters in there. Nate Adams got to go on the show. I got one on the show, and Bill Spohn was on the show as well. So we were represented because it wasn't just all the mold people, right? So it was kind of cool. Jason Hill did a great job. So if you guys want to look that up, it's a Got Mold Summit.
Very cool.
So I'm hitting on a lot of points, and you can tell the further we go into this,
there's a lot.
The further we need to go.
Yeah.
Yeah, it's like something like, and if you have the opportunity to go to John's class, it's not like a 4-hour thing. This is a multi-day. What is it, 2 or 3 day class?
2 days, 16 hours.
2-day class. It's totally worth it. It changed my life. One of the last things I wanted to talk about before we have to let you go is I think it would be criminal not to bring up your pride and joy right now. Your filter, the MERV 16 filter, that your product, the first product you've ever worked on, right?
Yeah, and thank you for that. And so I have to preface this by saying I did not invent the mousetrap. Okay? V-bank filtration's been around for a long time.
Yeah.
We built the best mousetrap because there's another product out there that's very similar to what we built, but ours is tenfold better. And so that would be the dust-free 16 or the DF16. So it is a true MERV 16. We have our ASHRAE 52.2 credentials. And so that wasn't good enough because that's what our competitor did. So we got our ASHRAE 52.2 credentials for the filters by themselves. Then we went to the next level and got our ASHRAE 52.2 MERV 16 credential for the whole system. That would include the filter and the housing. And so that was important because if you're going to go big, right? Our performance data is conservative because you have to be conservative with your published data. we're bringing a 4 and 5 ton unit at 492 feet per minute, right, at a 0.08 static drop. Now, I have contractors in the field that have installed these live on systems, bringing that 5 ton system in at a 0.06 static drop. MERV 16, 98% filtration, 3 years on a filter change, very robust electrostatic attraction using all 5 principles, 0.08, but bringing them in live at 0.06. And then the smaller unit, so that one has 4 filters in a W V bank. And then the other one goes up to 3 tons and it's in an N shape, but it's still V banked. And same criteria, we're bringing that in at a 0.06. But I've got guys in the field bringing them in at like 0.01, 0.02. Yeah.
That's
For
awesome.
for a MERV 16 at 98%
It's a
filtration.
3-year filter.
It is, and that's conservative. Now, this is subjective. If you live on a farm in Kansas in an old farmhouse with 15 dogs and 20 cats and geese and chicken and cows and 10 kids running in and out and grandpa's plowing the field and the doors are open,
Mm-hmm.
all bets are off. But this is a premium product, and people that need this caliber probably have a pretty clean house. Now, I'm confident if we have the right conditions, I'll get 4 years out of a filter. And it will never filter any less than 98%. We might at the end of the curve take a little hit on static pressure, but hey, 0.04 or 0.06, I got room for that, right?
Oh
And
yeah, for people listening, that's insane. Having something that low as far as a filter pressure drop goes.
yes, and another thing, it's all about surface area. So it's nanofiber technology, and that is how you choose the material, right? And how those fibers are woven, right? And so then it's 2.5 inch filter, and then we have a very robust front loading. But as those filters permeate, they'll never get all the way through. But our secondary loading has a very robust electrostatic as well. So that's why we're able to get that solid 98%. Now, I've got guys in the field that have sent me pictures of their particle scanner starting off, and they're like 300,000 particulates ambient in the space. So that's just their particle scanner sitting there. 15 minutes after installation, they're holding their particle scanner at the return air, and they're hanging out about 280 because it's starting to come down so ambient 300, 280 at the return. They go up to the supply and they're already down to 120,000 particulates per cubic feet. Within an hour or two of running that system, or they go back the next day, they're taking their particle scanner up to the register and it's zero, 100%
Wow.
filtration, and their ambient dropped from 300,000 particulates at zero point 0.3 microns per cubic feet all the way down to 40,000 ambient throughout the house.
Wow.
That is like unheard of. Unheard
That's
of.
awesome. And in the filter, the whole thing breaks down. It kind of snaps together. It's like it's like a little of a erector set, right? So
Yeah. So
that's interesting.
one of the problems was the bulkiness of it. So if it's assembled, it's pretty healthy filter, as you know, and so shipping becomes a problem, and so then it starts to cost a lot to ship a bunch of air that's in a box, right? So Devin, the engineer, I said, I mean, this would be great if it was knocked down. And so after we had the product, we went to the lab several times and we're right where we needed to be. And it went out to the floor for assembly. And he's like, John, you gotta see this. He showed me that. Yeah, how when you buy a present for the little kid and they play with the box. That was me. I geeked out on the box. So it's completely knocked down, 2 little boxes with handles. So when I used to do the competitor's version, I'd have to get it, disassemble it, take it into the attic, and reassemble it. or the same thing, get through a crawl space or a tight space. And so that was one thing that was so important. And so now the shipping is, yeah, a third of what it would take if it was assembled. And so, where can you get said filter? One might ask. So I'm glad you did. NCI has a partnership with True Tech Tools, and you can use your NCI discount code, and it will apply, and you can get them there. So here's something that just tickles me pink. They've been selling out of the 3 ton unit almost every couple of weeks. If you go to
Wow,
the website right now, they got two, and they just refilled the order like this
that's
week.
awesome.
Yeah, so they're selling. Um, not fully understanding distribution, but I'm learning. We are working on 2 point distribution and what it's going to take to get them into a supply house on the shelf. And being knocked down, it's all about shelf space. You
Oh
know,
yeah.
when you go to Walmart, it's all about their products are buying shelf space. So it's about the shelf space. So we're hoping to get that going. Dust Free has been acquired by Rector Seal, and so that they are a $6 billion a year annual income. They just bought Aspen coils, so they're going to get into that, and they're starting to revamp those to be A2L. I used to use Aspen coils all the time, but I think they've fallen behind a little bit because of SEER2 and a couple different things. So they just did that. So they're a busy company. So you got two main players. You got Diversitech and Rector Seal. So that's where we're at.
Very cool.
Awesome. Anything else from you, Casey?
Oh yeah. So now that I'm absolutely terrified of my own home, is it safer to live in a teepee outside than it is in my own house?
Well, it's good ventilation in a TV, but you got to have that fire to keep it warm. So I don't know about that. Yeah. So the thing is you're healthy, your girl's healthy. You know, it's people that are compromised that really we have to look at it. And it's not to say you shouldn't be concerned. I mean, it's nice to know, right?
Oh
So
yeah.
yeah, I guess I'm gonna have to swing by and I'll have to take it for a spin.
Yeah.
Nice.
Yeah.
All right, shall we wrap it?
Let's
Sounds
wrap it.
good.
All right, cool. You want to take it out, Casey?
No, that's all you, brother.
All
I'm
right.
learning from the master.
I'm not a master. Thank you guys. We appreciate your time listening. I appreciate Casey and John for coming on here. Both you guys are awesome people. John, you're a longtime friend. I continue to learn from you. I hope to continue learning from you for many years in the future. Um, and I just want to leave you guys with one last thing. If you're not measuring, you're guessing. Thank you.
All
Thanks,
right.
guys.
Thank you.